Can someone confirm me like whether you were able to see my screen or not?
Yeah, it's
Yes.
visible.
Yeah, thank you. That's good. Yeah, so guys. So basically, so this is the content like that we are going to be discussed as a part of AWS Cloud Data Engineering. So let's say first you can see the main components are so data engineering concepts and the AWS services. Like what are the different data AWS services that we are going to be deals with? So which are related to the a complete data engineering. Like let me just going for the inside deeper. Let me explain the data engineering in a nutshell. So, so, so basically, what is data engineering? So, before going to a data science, before the application is going to be handled by a data scientist, or before performing any data analytics, like we have to bring and collect the data into some organization, so some organization format. Okay. So for that, like the data is coming from the various sources. Let's say, as you know, the data file extension is a Excel, so the JSON, so CSV, so Parquet. The data can be stored into the multiple file systems. So these are the file systems basically. So if I'm talking about the databases, so those are the RDBMS, relational databases, or NoSQL databases, REST APIs. So these are REST APIs are not comes under the databases. So basically databases. So if I'm talking about the relational databases, that is the one of the main relational databases, the SQL Server and Oracle, Postgres, so etc. So we have multiple data systems, databases in the cloud and as well as the on-premise. Okay. So, and other source of data is the REST APIs. So what is REST APIs basically? So when you are using an application, so let's say when you're signing up into the one application, so by providing all the details, okay. So once you click on the send button, so your credentials or your user inputs is going to the server to validate. So that will going through the APIs in the format of JSON or else in the key value pairs. So this is also a kind of data storage device. So let me just go through the one JSON of the REST API. So you can see, so this is my API. So it contains the multiple objects and where the data is storing. So let's say user ID 1 is storing an ID and title body. So similarly, the ID 2 and 3, 4, etc. So this is the semi-structured data we can call it as. So this is also one of the data store. And similarly, flat files like XML, and also the data is coming from the IoT devices. So similarly, like we were getting the data from the multiple source systems. So as a data engineer, like what we have to do, so we have to integrate the data into the one single system. So whether it's a RDBMS or it's a streaming data, so anywhere. So we have to organize all these data and keeping into the one particular system. So for doing the analytics or any purpose, for building the any data visualizations. So as a data engineers, like we have to know the different data file systems. So basically data structures. Data structures, if I'm talking about the data structures, data is categorized into the three types basically. So the one is structured data. So all you know is the CSV files, right? The Excel sheet or the spreadsheet. So it's a combination of rows and columns. You can see the complete structure. Let me just open the Excel. Yeah. So any data you can just save it. So it's a rows and combinations. It has some structures. Rows representing the data number of rows we have, and the column represents their attributes. Right. So CSV is a perfect example for the structured data. Also RDBMS, relational databases. Right. Let me just open this SQL server and show you the data how it is hosted into the RDBMS. Okay. So let it open. Meanwhile, let me just discuss about the semi-structure. So the second one is the semi-structured data. So the JSON is the main object. Okay, then let me just show you the SQL data. So, so you can just see. So this is also the data which is stored into the RDBMS is also a rows and columns. So that's the reason like all the RDBMS data is structured. Right. No? CSV and the RDBMS are the main source for the structured data. So semi-structured is the data it has some structured, but that is not into the rows and columns. Let's say JSON object, or else you can just take it as an API also, because API also stored in the form of key and values. So let's say you can just see. So this is one data points. Let's say this is one record. I can say because user ID is my column and ID is the one column and title body. These are the four columns I have and their values. Right. So this is not completely into the structure. So let's say if you wanted to make this data to the structure, so let me just show you the some sample Python program. So where I'm just converting this data to the structure. Okay. So let's say this is my API. I'm just trying to read this API data using Python code. So let's say you can just see the data has been read from this particular API. So this complete particular data has been read from here. Okay. So what I'm doing here, so using some libraries from the Python, I'm just converting into the structured data, as you can see. So let's say take one example. So what is the first object we have? User ID and title body, right? So these are the main columns. As you can see, after converting into the data frame, so you can just see, so the all the keys are converted into the columns and their values has been converted into the rows. So this is how like we have to manipulate the data as a data engineer, like we have to handle the multiple data systems, whether it's a structured data or semi-structured data, any complex data we have. So we have to convert them to the structured data for doing the data analytics. Let's say after converting this semi-structured data to the structured data, what I have did, let's say I'm just trying to understand what are the different unique IDs I have. Let's say IDs I have duplicated here. Right. What I'm doing here, so I'm just trying to get the unique IDs and also doing some grouping operations. Let's discuss later point of time, so don't worry about it. So, but as I told you, like the any data structure, so because this is the let me just discuss the third one. So that is the unstructured basically. So most of the time, like we cannot deals with unstructured data because unstructured data is comes under the complete data files which are not able to do analytics. Let's say audio files, okay, some video files from the YouTube. So or any systems. Basically, these are the blob storage we can call it as. So these things we cannot deals with as a data engineer. Okay. So most of the times, like we are going to be deals with the structured data and semi-structured data. If it is semi-structured data, we can use some tools from the Python and make it to the structure. And then for the data analyst or the data scientist, we have to make sure the data is available for them to do analytics. Okay. So this is the basic overview of the data analytics. And let me just go back to the course structure. So as you can see, so the data engineer concepts anyway we are going to be deals with. So fetching the data from the external REST API, as you have seen, right? So this is my API. So I'm just trying to hit this API and gets the data and doing the manipulation. So using the Python code. So similarly, fetching data from the SFTP servers. As you know, like we have the different servers. So data itself, it's a server. Okay. So let me just. So this is my server, right? So from this particular server, have the multiple databases, and from here I need to extract the data to the manipulation. So this is basically fetching the data from the SFTP service. Like, so ingesting data into the databases. Let's say I have this database. So I wanted to ingest some data from the outside of this particular system. So using Python, we can write some automation scripts. So those scripts run on top of the databases and ingest the data to the different systems. And also creating a serverless data lakes using the S3 and Athena. So S3 and Athena is from these are the services from the AWS basically. So what is S3? So S3 is basically a data lake where you can store all the data files like Parquet, different file format systems you can store it in the S3. So Athena is basically a query language, a query editor basically. So where you can just write a different queries, same like here. So I'm just writing some query and pulling the data, right? So similarly, so Athena is a service like where you can just write the multiple data analytics queries and pull the information from the different source systems. Here S3 is the one of the sources. So then after like we are going to be deals with the ETL jobs basically. So what is the ETL jobs? So ETL is the main concepts you should be know as a data engineer. Okay. So let's let me just abbreviate this one. E stands for extracts basically. So T stands for transform, and then L stands for the load. So ETL is majorly focusing on the data availability. So let's say extraction. So I wanted to let's say I'm just running my supermarket. Okay. So my data has been storing into the different particular systems. Let's say some of the data is I'm storing it as in the Excel files or CSV files, and some data is connecting to the databases. Let's say I'm just doing a transaction through the some QR codes. So those data can be stored into the databases. Let's say some manual entry has been happened to the Excel system. So I have to integrate my data. So from these two source systems, I have to integrate my data and put it into the one system for doing the data analytics. Let's say I have done in a past week, like I've done like 100 transactions. Okay, out of 100 transactions, 60 transactions are has been entered to the Excel systems. So other 40 records has been entered to the database systems. For doing the data analytics, I have to integrate these two particular data systems, and then load to the put it into the one particular system. So the target is the let me just explain the these things. So the extraction basically. So I have to extract the data from these two particular systems and then transformations. Let's say in the database I have some 10 records. ID, customer name, and then transaction ID, transaction amount. Right. So let's say 101. So name is some XYZ. So transaction ID is some 12456. So the transaction amount is let's say 4000. So similarly, I have the multiple systems. Those are stored into the database, the table name called transaction. Okay. So this is my table name. Similarly, I have an Excel file as well. So where I'm just maintaining the data. So this is basically customer address, okay, number of quantity, okay. So then unit price and then total price. Here also I have the ID of the customer, right? So let's say the 101 is the customer ID. Customer address is something else. Okay. Number of quantity purchased is the 5. So unit price is let's say one particular item cost of to 200, and then total price I can calculate it as 1000. Right. So this is how I have the information from the multiple systems. So let's say from the transaction table, how much amount has been spent, and the Excel sheet also I'm just getting some informations which is related to the customer address. Let's say 101 customer address I'm getting from this Excel sheet, and the number of quantity and other details are coming from here, and some of the details are coming from here. So I have to integrate these two tables, get it into the one the final table. So let's say the final table should be I have to load the tables ID, customer ID and name, and the number of quantity purchased, and also unit price, right? And then total price, and also I just need the transaction ID. So I'm just combining some of the columns from the these two source systems and making a one final table, right? This is my final table. So I'm just using these two tables. I'm writing some scripting language, anything that is Python or SQL, and do the manipulations and get this particular table. So that's where the ETL is comes into the picture. So extracting the data from the multiple systems and then do the transformations. So if I wanted to uh, get the information from the both tables, I have to use some concept called join from the SQL. So joins are basically used to combine the data from the multiple tables and then put it into the one particular system. So I can use the join concept between these two tables and get my final table. So that's where I can call it as a transformation. So the join is a transformation here and loading the data, the final data into the one particular system. After all the transformations has been done, I'm just saving it as a new table as a final table in the database. The same database or the different database based on your requirement. So this is the ETL basically. So extracting the data and then transforming the data and loading it into the one particular system, one particular database that could be majorly in the databases only we can store the data for doing the analytics, data analytics. So after I got like all the final tables, I can do the analytics. How many customers has been purchased, how many items they have purchased, and what is the unit price and the total price. Let's say maximum amount they have spent. Or what are the customer IDs? They have spent the maximum amount in this particular last particular week. Like all the analytics I can do on the final tables, but I cannot. So until and unless I'll get a final table. So using the some ETL operation. So this is where like we were using the ETL operations to get the data can be integrated. So exactly. So the creating glue ETL jobs is nothing but a, so we are connecting to the multiple source systems using the glue and then doing the transformations and then loading it into the database. So once you have done move to the data to the final database, you can just perform the different analytics on top of them. You can the data scientist like directly can use that particular data and performing some different ML operations, tuning the data and forecasting something. So based on the previous data. So that is not part of this particular curriculum. So as a data engineer, like we have to integrate the data and then transforming the data and load it into the target systems. Okay. So this is about the ETL service from the AWS and then transforming data into the Parquet format. Once you have transformed the data, you can write it into the multiple file systems as I told you earlier. This could be into the where I did. Okay, don't worry. So you can just save your files into the CSV format or JSON or Parquet or ORC. So etc. Like we have some 10 file systems we have. Once we all go into the deeper, like I'll explain the each file systems. What is the importance of the each file systems and when we have to when we should we use that particular file system. So when we cannot. Yeah. So then learn how to store the data into the S3 data lakes using the Parquet columnar file formats. So in the S3, as I told you, like we can store the multiple file formats as a part of this particular curriculum. So I'll show you uh, what are the different file systems, how we are going to be store it, how we can automate using some Python or the SQL script. So those things we can discuss in the later point of time. So in this particular course, so we majorly focus on the SQL from the scratch because as a data engineer, like you have to interact with the different databases. So because as per the business requirement, like you should be able to write a different logics. Let's say some particular, let's say one business use case. Let me explain the one business use case. Okay? So get all the customer informations who have purchased items which are. related to the electronics. Let's say electronics and spent more than average price. So this is the one particular business use case, guys. So this will this information this particular business I'll get from the business. So what they were asking is to get all the customer informations like who have purchased the only which who have purchased the items which are related to the electronics only, which comes under the electronics only, and spent more than average price. So let's say I have the 1 billion rows. Okay, so it can have the multiple. So let's say purchase item could be anything. So it's electronics. It may be electronics. It may be a clothes. So it may be anything. So but he only wanted to do perform some analytics on the electronics. So we have to filter the electronics rows, so the customer informations which are underlying on the electronics, and then so we have to calculate the average price. Let's say if it is a SQL, let me just write a sample query, but don't worry, like if you are not understanding, that is also fine. Okay, select star from table. Okay. It contains a my table is contains a 1 billion rows. So what I'm writing is where item purchased. So this is my column basically. So let's say what I'm putting here electronics. So out of 1 billion rows, I'll get some 30,000 or 1 lakh rows has been filtered out after running this query. Because this particular query filters only the electronics purchased items, the customers who are underlying on this particular electronics, right? So after that, like what should I do? So the next question is the electronics and spend more than average price. So once you have put this star means you will get all the columns, guys. So after that, what I'm doing, so average price I'm calculating it, average price. So here I'm just calculating the average price using the grouping operation. If you do not understand, don't worry, okay? So then having price is greater than average price. So don't worry, like what I'm doing is here, so calculating the average price. So once I'll calculate the average price, here I'm filtering. So my price should be greater than the average price. Right, in the each system, so in the each uh, customer id and the each particular product, so I'm just calculating the average price, and my price should be greater than this particular average price. The customer price should be greater than this particular average price. So this is how you have to write the some logical queries using the SQL or Python, so that is anything. So that's why like we were teaching you the both from the scratch basically. So what is the data types and the operators and the database creations and everything. So what these are the DDL commands we can call it as. And what is the DDL means? Data definition language. Let's say you are going to create some table. So you have to give the some definition to the particular table. Let's say id. So id, what is the definition? So it's a id is related to the some kind of integer. So name, it's a varchar. So that is the definition basically. So we have the ddl commands. At the same time, we also have the dml commands where you can just do the joins and the aggregations and filtering the data. I write some where class right here in the particular query. So this is my DML commands. I'm just trying to manipulate the data, existing data, and get the results according to the business. So in the as a part of DML, so you can just learn the these many concepts. Those are the joins and constraints, aggregate functions, and the window functions and filterings, uh, data handling duplicates, right? Date functions and view stored procedures and common table expressions and union all. So everything we can discuss later point of time and deeper. So that is the overview of SQL and Python. So you guys know because the Python is nowadays like it's a everywhere. So Python is used in the data analytics, the machine learning, computer vision and NLP, natural language process, data science, like all the across the any software application. So Python is the main part. Like even the testing. People are trying to automating some things using the Python scripting, right? So Python is more flexible to do the data analytics as well. So as part of data analytics, we were going to be deals with the main core libraries. Those are the NumPy and Pandas and C1 and the Matplotlib. So NumPy and Pandas is mainly useful for the data manipulations and the data fetching. And the Seaborn and Matplotlib is the whatever the data you got, like you can do the data visualizations. So for the visualizations, so these two libraries are the main. So these are the four core libraries we are going to be covering. So apart from that, so we are also going to be cover the basic programming from the any language. Let's say even Python also have some basic concepts, right? Data types and what is variable and what is the loops and date functions are the everything from the basics. So this is in deeper about the NumPy, and this is uh, more clear on the pandas as well. So what are the different concepts we are going to be deals with inside the pandas, sorting, the reindexing and data frames creations. You have seen, right? So this is the data frame. So data frame is nothing but it's a combination of again rows and columns. It could be a structured. Okay. So once you are converting into the data frames, how we are going to perform the grouping operations or the window functions, aggregate functions. So whatever the concepts you have learned in the SQL, same concepts can be come here. So but the syntax could be little difference as compared to the scripting language and the programming language. So window functions and aggregate functions, these can be we can cover in the SQL as itself, but still we can see in the Python as well, right? So these are the some key features of the pandas. Let me just discuss later point of time. So once we have done with the one scripting language and the one programming language, so how we are going to be communicate with the AWS. So inside the AWS, basically, first we can introduction about the we can give the overview of the AWS, like what are the different systems we are the AWS is offering, like SaaS, PaaS, platform as a service, and software as a service. So what is the different infrastructures we have in the AWS? I can explain you. I'll walk you through those systems. And so once that is done, so the only the data engineering services. So which are the data engineering service we should be focused on. So those things I can guide you. So, as a part of data engineering services, we have the S3. It's a data lake, as I already discussed with you. Storage services it is, and then then after like IAM. So IAM is the identity access management. Let's say if I have created a one S3 bucket, so I'm just accessing from my end. Let's say you also needs to be access the same bucket means, so I can give some privileges to you to access my bucket. So that's where like IAM is the comes into the picture. So just giving the identity access management, how you are creating the different roles and giving the permissions to them, and the restrictions basically, right? So and then after the AWS Glow, this is the main service from the AWS. As a data engineer, like you should learn this technology thoroughly. As I told you, like all the ETL operations can be performed here. Athena. It's the same like querying language, same like a, database, SQL Server or any other query languages. So then after we can move to the Kinesis. It's a real-time handling data, streaming data. How we are going to be perform the real-time data capturing, and then how we are doing the data loading part, and then performing analytics. So and then Redshift, the data warehouse. As I'm discussing with you, right? So loading the data into the any database system. So inside the cloud, we were using the Redshift as a loading part. It's a database basically. So you can just dump your data once you are transforming your data. You can just load it to the Redshift. So from Redshift, you can connect to the Power BI or any data visualization service to do the analytics. Right. So then after Lambda functions, I'll discuss. It's a function basically. It's a serverless function where you can just write your script. So that will automatically trigger based on some events. So then after Boto 3, it's like a library. I'll explain how it can interact. Let's say we have to create some bridge, right? Let's say my Python script needs to be communicate with my AWS. So that's where the Boto 3 has been comes into the picture. It's a Python library. It can communicate to the AWS services and different data operations, copying the data from S3 to Redshift or Redshift to S3, writing some lambda function so that can put some files from the external source system to the S3 bucket. So means on-premise to the cloud, cloud to the on-premise. So the catalog tables. It's a crawler is also a part of loop. I'll explain when we're going to. Once it has been done, like we will providing the all interview questions on as a part of data engineering. So what are the different business scenarios comes in the interview point of time, and also in the AWS different data services and their importance. So let's say if you're facing some issues in the while building some data pipelines, so how you're going to be handled. So those things can be on real time. So we can once we have done the basics of SQL and Python. So once we have entered into this AWS, so where you are going to be using this expertise like Python and SQL expertise and build the data pipelines. Let me explain the data pipeline quickly. Data pipeline. Okay. So what is the pipeline, guys? So moving something, some object to the other place. Same here, but I'm just trying to moving my data using this pipeline basically. So let's say AWS Glue, you can just take it as. Since it's a ETL service, what I'm configuring here. So extracting the data. As I told you, the data is coming from the multiple source systems. Let's say 3 or 4 is my source systems to build my use case. Right. So my use case is basically uh, let me just write in the below. Get the customers info along with the sales in the month of let's say in the month, okay, in the month of December of last 2 years. Okay. So this is my business use case which I got from the business. Okay. So what should I do? So first, let's say once you'll get the business use case, you have to understand the source systems basically. So as the end user, as the business owner, so we have to raise some request to them. So what are the different source systems you are using? Let's say you will come up with a next reply, something like let's say you are raises some email, put some email to the business. So can I know your source systems? Okay, right. So then the business has been replied to you, like we have SQL Server and REST API and CSV. So these are the source systems. Okay. So then, so what you have to do? So you have to raise a access request to the these particular databases. So along with that, like they will give the server ID. Let's say, suppose this is my database, right? Let's say you can assume it as a database. So I'm just connecting to this database. So I have to raise a request to access this particular server. So they'll provide the server names as well along with this server names for these things and REST APIs. Maybe they will give some information about this. So what have to you have to raise a request, access request to the all source systems. Okay. So once you will get the access, you can just log in. Let's say I got the access for the database. Okay, this particular database, RDBMS, so that is a SQL Server. So what I can do, I can go to the databases. Let's say this is their the business database. I can have the customer informations I have here. So this particular table, what all are the different attributes we have? Let me just see the attributes. So it contains only the customer ID and the customer name and address only. So, but what he was asking basically, get the customer informations along with their sales. So in the month of last December, so means the sales informations can be coming from the different source systems. This is not coming from the RDBMS because in the RDBMS we have already queried. There is no sales related data we have. So what we have to do, so we have to analyze the source system again. So go to the next source system. What is the next source system? So there is a REST API. So as you guys know already, so how the REST APIs looks like. So let's say the sales. Let's assume basically instead of user ID, let's say customer ID. This is and the sale amount, and then something purchased item, and the date. Date also we have because we have to filter the data of last 2 years in the month of December. So as you have seen, because we have the two source systems, one is RDBMS and one is the REST API. So we have to build this particular use case using the two source systems, right? So using the glue, what you have to do first? So make a connection to the database first of all, and then REST API. How you are doing a REST API? I've already shown you one some sample Python code, right? The same code you can use it in the glue basically. So you can just write these two lines of code and get these informations. Okay. And then what I can do some transformations and converting into the this particular data frame. It has rows and columns now. So similarly, this particular information also have some rows and columns. Means now the two source systems have converted into the structure. So now this time I have the customer informations can be into the form of structure, and also sales information is also into the structure. So using these two tables, I can join, right guys? And using this, there is a join concept I have told you. So using these two tables, I can merge these two tables using the joins concept, and then build my final data analytics this particular use case. So that's where you are trying to performing the extraction. So extracting the data from the REST API and as well as the database and transforming it. Let's say because since it is a unstructured, I'm just trying to make it as a structure and then loading it. So before loading, you can perform some calculations like month you're calculating and filtering the data. So where let's say uh, here what you can just write it, select customer info is coming from database, right? Customer ID. What else we have? Customer name, because he's asking the customer information as well. So address, from which database this is, customer table, right? So what I'm doing here, just joining it, right? So what is my data frame? So this is my data frame. This data frame contains the sales information, right? Sales information. So once you perform it, once you have joined it on the basis of some column, let's say in the customer table, I have the customer ID. Similarly, data frame dot ID. This also, because this is a column. This is a common column. I'm using it and then joining the table. So then after, once I'll get a join, so customer address is coming from the customer table. So what is the columns are coming from the data frame, guys? So let's say sale ID, sale amount basically, sale amount and some unit price. So these are the two columns coming from the data frame, right? So I just need to filter the data of last 2 years, unit price and also date, date column also you are getting. So where date is, here I'm just putting a filter. Right. With date in condition I'm just using last 2 years means the current year and the previous year, 2022 and 2020. So it will filters the years and get the information, right? So this is how you have to write a query to pull the data from the two tables. This is a transformation logic basically, the business logic you have to build it based on the business use cases. Once you extract the data from the multiple source systems, and then you can perform the transformations. And once you will get the results after running this query, you can just put it into the some database or the anything to perform analytics. So that's that is about the complete detail. So as a part of data engineer, cloud data engineer, we must be focused on the ETL side, and then storage services like S3 and DynamoDB, and then Glue jobs, especially for doing some analytics. uh, extraction and the ETL operations, and then Kinesis for the real-time data operations, and the Lambda functions, and Athena to query the data from different source systems. And yeah, pretty much this is about the course. So as a part of prerequisites, if you have the 2 years of hands-on experience working on AWS, but this is not required because anyway we are going to be covering in this particular course, we were going everything from the scratch only. Okay, so everything from the scratch only, as it's a programming language or the scripting language or that is anything. So we are mostly focusing on the basics, and then moving into the AWS. So inside the AWS also, we are not going to be cover all the concepts, only the concepts which are related to the data engineering.